All right, so let's say we got double-stranded break, right? A, B, D, E, F. And then there's another chromosome here that is totally fine. Like this. Okay, so the first thing that happens, well, first, okay, so just know that these are all 5' and these are all 3'. The first thing that happens in this process is resection of these ends, right? So just remember that most of the exonucleases in this entire thing are basically 5' to 3'. So what's going to happen is resection is going to like chew up this part and then chew up this part. So if we draw the resection product, and now from now on, just assume that everything on here is 5', everything here is 3', because it's just like way easier. So after resection, we're going to have something like this. We're going to have AB on one side, and then this is the stuff that's chewed up, and we have F remaining here. Okay, now on this one, we have an A here, because remember this is 3', 5', so it chewed up this way. So we have A remaining, and then we have D, E, F, and the original strands down here that are all A, B, D, E, F, they're untouched because, you know, they're perfect DNA. They're what we're using as a template, so nothing can really happen. So the next step is where this strand right here invades this area here. So you can imagine like this strand gets kind of like pulled up like that, right? Pulls up, and then this gets pushed in, right? And the real reason this is happening is because it's coded with RAD51, right? And BRCA2 is what loads that on after it's coded RPA, blah, blah, blah. And RAD51 is doing this sort of homology search. So in reality, like this strand, this DEF isn't necessarily perfectly positioned right next to this DEF. It could be somewhere way down. So what's going to happen is this strand is going to go inside of here and kind of start moving along here and looking for the homology, right? So anyway, so we're just going to draw it like as if it's found it already, which is, I think, what they want on the test. I don't really know. So we have this, and then we have A, and then what I think helps the most is like immediately drawing this little like hook down here, and then just filling that in. So F, E, D, right? Because this part of the strand, see, like this moved down here. So F, E, D. And then that's all, like, I feel like that's easiest to draw right there. So that's all you draw. And then you draw the, what would be here is A, and then something has to go up here to fill in the rest of that strand. So there's complementary base pairing, right? So what happens is this D loop formation happens because this strand invaded here and pushed it up, right? So now it has to be base paired with something. So B pairs with B here, and then D is here, and E is here. And then lastly, F is still here, right? Because these, like, one thing you have to do is whatever's, like, in the beginning here, whatever strand is fully connected here, like, it has to be the same genes on the same strand because nothing has crossed over yet or separated. So if I draw a line that goes up, up, that goes right, up, right, down, right, anything along this line has to be identical to this gene here because they're the same strands of DNA, they just moved. Okay. Now I'll draw the bottom DNA here. And if you look, I didn't draw anything further here because there was nothing further here. But essentially what would have been happening here is this strand would invade here and then start kind of moving around looking for homology. And once it found it, it would lock here. Don't quote me, but I think that might be what branch migration is for. I don't know yet. I need to look it up because I'm not done studying. Okay, anyway. So now what's going to happen is the polymerases are going to fill in all the 3' to 5' ends like before, and we get this. So, and they're going to use this thing as a template. So whatever's missing, they're just going to use a template. So first, let's just draw what would have been filled in, right? So like this would have been filled in, and this would have been filled in, right? So and then like right here, this would have been filled in, right? But let's just draw it more formally over here. So the first thing I'm going to do is I'm going to draw the top strand all the way connected because it's been polymerized and ligated. So now we have D star, E star, and then F, right? Okay, now this bottom strand here supposedly has been fully polymerized, right? And ligated. So what we'll have is we'll have A, because we have an A here, and then we'll have this little formation here, right? Because if you notice, this strand is already down here. There's nothing we can do. You know, the strand can't magically move back up, right? So it has to ligate from here to here because it needs to preserve, like, I mean, also there's nowhere else for it to ligate to. Like, it can't ligate here because this is already connected to something, so it has no choice but to ligate here. So we have B star, because they lined up here, right? B star, and also it was replicated by using that as a copy. And then we have D. Oh, sorry, we have this is a capital D, right? Because we have to follow the strand. So this is a capital D, capital E, and then capital F here, which is correctly paired. Now we have to fill in this strand, which right here, strands goes over. And if you remember, this strand has to stay, there's a crossing here because this strand had to stay above here because it formed the D loop. So now the easiest thing we can do is we don't even need to know what the replication products were because this strand that's formed this D loop is identical to this one here. So it's just going to be A, B, D, E, lowercase f, right? Because it's totally unchanged so far. And then same thing for the bottom one. This is totally unchanged because nothing happened to it. And that's the way it should be, right? These two pieces of DNA, this strand and this strand, were originally paired up here. And throughout this entire process, nothing has changed them because they were used as a template. Okay, now, if you look here, we have heteroduplex DNA here. We have them here, we have it here, and we have it here, right? Oh yeah, and wait, actually, sorry, other way around. We have heteroduplex DNA here, 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 whatever. It's basically, I mean, like, basically these two things are paired and these two things are paired. So sorry, I shouldn't have circled the middle because it's important to remember that within these two middle strands, there's no pairing going on, right? Like, these two strands are not paired to each other. There is pairing going on here, but it's like more complicated, and it's not the same. It's not what you're thinking of, right? So these top two strands are paired and these bottom two strands are paired, and that's just the way it is, right? So now to draw the rest of the splitting products, I'm going to move on to a different page because there's I think 4 different ways this can split. So give me a sec, I need to copy it over. Yeah. I'm gonna go to Trader Joe very quick. Okay, that's fine. All right. Yeah, they're here. Sorry, that was my dad. Anyway, so E, F, and then draw that. Oops, it's not the neatest, but remember, it should be easy to fill this in even if you aren't looking at the previous diagram, because these are the exact same strands. They haven't been changed at all. Oops, sorry. D, E, F. Okay. So now we need to look at the resolution of the Holliday junctions, right? Okay, so in my opinion, the number one absolute easiest way this thing can resolve is two site 2 cuts. And remember that site 1 is right here, and then site 2 is right here. Site 2 is like the absolute like the double site 2 cut is the absolute easiest way you can recombine, because it's essentially this little cross just disappearing, and that's it. And you just copy the lines that you already have. So, and the reason that happens is because these points kind of like are joined into a loop like this, and they kind of just move back into place and seal up. So if you had two site 2 combinations, it would be very simply ADEF, ABDEF, ABDEF, ABD. Sorry, this should, yeah, DF. I didn't really draw it very neatly, but the point is they all line up, and it's incredibly simple. And it's like the exact same thing as here, and there's also no crossing over. Like this gene is entirely fine, the same. And this is a non-crossover product. Okay, so let's look at the totally reverse case where they're both site 1 cuts, because I feel like that's also not too bad. So I'm going to box this because it's one of our answers, but I'm also going to, and let's label it 2x2 because it was a 2 site 2 cuts. I'm going to draw like an intermediate for the site 1 cut because it's a little bit more complicated. But essentially, since they're cutting here, 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 and here, I'm going to draw breaks there already, just because that's what's going to happen anyway. I don't know. And then we have F here, right? So now I'm just going to draw this as normal. You'll see why in a sec. Well, I mean, maybe I hope that's what I'm supposed to do. I'll check with the SI sheet in the end of this video, like before I send it to you guys, to make sure it's like actually correct. B star, D, E, E, F. Again, this strand, totally the same. It's just displaced, right? Totally the same as it was in the beginning. And then there's a cut here, right? Because that's where the site 1 cut would happen. G, E, and then F, because it's a site cut. Okay. So in this Holliday junction resolution, what happens is essentially this strand gets joined all the way up here, and this strand gets joined all the way up here, okay? Same thing with this one because we're doing 2 site 1 cuts. So here's how this is going to work. I'm going to draw my 4 lines of finished DNA, I'm going to start at the top and read sequentially in the order that the strands are connected, right? So if you look, this strand is connected here, and this strand connected here. So it goes A, B, D, E, F. That's the final order. A, B, D, E, F. Because I'm following that loop. Now, the next one, we're going to act like these Holliday junctions were still permanent. And in a sense, they kind of are, because what happens is these strands kind of move past each other like that, right? But anyway, if you don't care about that, you can just read directly where the strand tells you to read. It's A, B, D, E, F, like this, because that's the way it's connected. So now the next strand is A, B star, D, E, F. And now we're going to read the bottom strand, A, B, D, E, F, because that's the way they're connected. So A, B, D, E, F. And now if you look, there's no crossover, right? Because this is the exact same strand there was. That's totally unchanged. So this is a non-crossover product. Now, we're going to read the last strand. And if you look the way it's connected, it's A, B, D, E, drop down F. So now we have A, B, D star, E star, F. And that's it. This is the site 1. This is the site 1 recombination, or sorry, it's the double site 1 Holliday junction like recombination or whatever. Okay, so now we're going to do the more complicated ones, which do result in crossover. So one thing to remember is that if the site resolution are the same sites, so 2, 2, 1, 1, there's no crossover. But if the sites are different, like 1, 2 or 2, 1, then there will be crossover. Okay, so I would recommend drawing this structure. Let's do a 1, 2 site. So 1 and then 2. I would recommend drawing this intermediate structure on like the back of the page somewhere, just so you can keep track of everything. But what's going to happen here is the first site is going to be a site 1 cut, right? We're going to have A, B, D star, E star, F, right? And this is going to be broken here. A, B star, D, E, F. And now we're going to have A, here we go, A, B, D, E, F. Now, we're doing a site 2 cut on the next part, right? Right here. And remember, that's the super easy cut where these strands just join. So what I'm going to do is I'm just going to totally erase this and just draw a connection here, because that's what the site 2 cut did there anyway. And now we're going to continue on with our site 1 cut, which would be B, D, E, F. Okay. Now, if you remember, what happens here is this connects to here, and this connects to here, right? So when I'm drawing my final 1, 2 product, I'm going to start off by drawing 4 lines here. And I'm just going to follow the strands, because the strands tell me exactly where everything goes. So if I follow the top strand, it goes A, B, D, E, F. Okay, so I'm going to draw that. A, B, D, E, F. And now let's go on to the middle slide. And the middle strand goes A, B, D, E, F, like this. A, B, D, E, F. And I get this. And if you remember, when there was 2 site 1 cuts, we actually went A, B, D, E, and then up again, because there was a Holliday junction here that was unresolved, because there was a site cut here. Now we can follow the bottom strand, A, B, D, E, F. And the only reason we're continuing on this top strand is because there was a site 1 cut here that ligated them like this, kind of just like eliminated that crossing. So we're going to fill it in, A, B, D, E, F. All right, now we're going to follow the bottom strand. So it starts off A, and then it goes all the way up to the top and goes B, D star, E star, F. And then that's it. That's the entire, that's the 1 by 2 site crossing, okay? And then what that gives us is a crossing over product, because look, none of the original strands are the same. They're all different. So this is a crossing over event. And if you can't remember that this is that's how you tell it's a crossing over event, just remember that this is different, 1 and 2. They're not the same sites, so it's crossing over. Okay, so we're going to do the last site now, and it's going to be the 2, 1 cut. So I'm going to do the same thing I did. I'm going to draw, well, first, remember, we're going to do a 2, 1 cut. So what I'm going to do is I'm going to just draw this top strand normally with a break here, an F, A, B, D star, E star, F, and I'm going to draw it like this, right? And there's a break here because that was our site 1 cut. Now I'm going to draw the bottom strands, the middle 2 strands totally normally, because when a site 1 cut happens, none of the middle strands are affected at all. So here's our double Holliday junction, and we're going to have A, B, D, E, F, and A, B star, D, E, F. Okay? Now, what we can do now immediately is remember that there's a site 2 cut first. Remember? So what happens is this totally goes away, and these are ligated. So our site 2 cut we just solved our site 2 cut already. And now we need to go do our site 1 cut that happened next. So copy it exactly as it is. Look, D, E, A, B, C, D, E, F. And there's just a break here. And then we draw this all the way up here. And we draw this all the way down here. And I don't think you should write this intermediate on the test. I think you should use scratch paper somewhere. Because I don't know if that's what they want. And this is not like totally what happened. I mean, I guess it's pretty accurate what happens, but this is just like the easiest way to think of it. But anyway, so now we're just going to follow the strands like we did last time. So A, B, D, E, and then this all goes all the way down and goes F. So A, B, D star, E star, and then there's an F. And then we're going to follow this strand. And look, we're not going down here because there was a site 2 resolution here and it ligated directly across from it. So now we have A, B, D, E, and then F because there was no site 2 resolution here. A, B, D, E, F. Now we have another one where there's a site 2 resolution, so we go right across like we drew before. We already drew this, by the way. I'm just explaining why we drew it that way. A, B star, D, E, and then back up here because there was no site 2 cut here. Now lastly, for the last bottom strand, we go A, B, D, E, A, B, D, E, and then it goes all the way up, and then it's a capital F. And then that is the final structure that we have to write on the paper. And if you look, this is a crossing over end because none of the strands are the same. We have a modification here. So our final products are this one for the 2x2, this one for the 1-1, this one right here for the 1-2, and this one right here for the 2-1. And these are the only 2 crossover products, and these two are non-crossover products. And that's it.